happy that the Nilgiri Natural History Society is organizing these webinars, providing a lot of information for the environment, regarding the environment. I in fact attended some of the webinars, especially the recent ones on the wildcats. They were quite interesting. In fact, I have something on wildcats as well. You can see a tiger hiding from the brown vegetation. That shows some impact of some extreme weather event on the wildcats as well. So and thanks for the newsletters. I got the newsletters from NNHS. If you guys want to know a lot more on NNHS and Western Ghats and activity over there, that's one point to check out their website for the newsletters. So coming on to my institution, I'm working at Indian Institute of Tropical Meteorology. We call it IITM. It's under the Ministry of Earth Sciences. And we have about 150 scientists over here working at IITM. And some of us work on climate change. And as you all know, many of you might be aware of climate change. Let me enable my light. It's a pointer. So almost all of you have heard about climate change and also probably faced its impacts as well. Many of you might have faced it directly, or it may be your family, or it may be your neighbor. Some of you might have felt the impacts of climate change. And so we know that it's on our doorsteps or at our neighbors' doorsteps. And in this talk, we will explore how climate change is churning out extreme weather events all over India, one after the other, both over the land and over the ocean as well. And as Sharada mentioned, I'm a climate scientist. So we explore the science behind these weather events, extreme weather events, and explore the physical mechanism. But in our studies, many times we have seen how it impacts the life around, both the human life and also the biodiversity, the animals, the plants, the birds, and the marine life as well. So we will touch upon some of these impacts of climate change and extreme weather events. I will call them as stories in the marine ecosystem, stories in the avian ecosystem, stories over land as well, the terrestrial stories. So we will go through some of these extreme events and their impacts. So if you look at this chart, I will keep this talk very simple. We will have a few charts with a little bit of pinch of science in it, so as to explain the basics of climate change and extreme events. So this chart shows the change in temperature, the global change in temperature during the past several decades. It starts from 1880s to 2010s. And if you see, there is a phenomenal, or there is a monotonous rise in the temperature during the last several decades. And if we look back, we can see that we are in fact living in the warmest decades ever recorded in the human history. And there is no turning back. This ladder is going up. So we are living in these warmest decades. And this is churning out these extreme weather events over India. So is there a comeback? Is there can we take a U-turn so that these extremes are no more, and is it a happily ever after story? So that's what we are going to explore here. So now we saw this chart of the warmest decades, the recent decades, how the temperature has changed. So you can see the 1.2 degrees Celsius shown here. That is the global average. So that much temperature change has happened in an average. But for this doesn't mean all regions have the same temperature change. Some regions, the temperature change might be 2 degrees, 3 degrees. Some regions, the temperature change might be lesser than that. And if we dissect this temperature change in these decades, we can see how much temperature change has occurred in each year. And that's the bottom graph, which you see here, bottom chart. And this displays the top 10 hot years ever recorded in human history once again. And is there a number, is there a year which starts with 1? No, all years are starting with 2. So which means that all top 10 hot years happened in the recent decade, the recent 2 decades after 2000. And if you look closely, most of them are after 2010. So the first two, 2009, 2005, then it's all 2010s. And 2019 is the second most hottest year which has been ever recorded. So this has implications on the ocean, on the land, on the biodiversity as well. So now coming to extremes, we will have a quick glimpse at what all extremes we have been having over India. So this is a picture sourced from the Center for Science and Environment Down to Earth in the State of Environment 2020. The data is sourced from Indian Met Department. So this shows how the extremes are scattered all over India. It can be a bit scary if you look at the extremes. The top line says 19 major weather events claimed over 1,500 lives in 2019, and among them, the most of these extremes are floods and heavy rains. So these green lines which you see, those are the floods and the heavy rains. And then you have snow-related avalanches or cold waves over some regions. We have heat waves over some regions, and lightning over some other regions. So many extreme events. Human memory is quite short, which is why I reminded you about 2019. We will go into 2020 soon. And but this is not all. We have quite a lot of extremes over the ocean as well, which has a direct impact on us also. Direct impact on the monsoons, direct impact on the water we drink. Now, let us zoom in on to the extremes in 2020. Here you see a lot many pictures. So 2020, along with COVID, we saw quite a number of extremes, to say. Both on the east coast of India, west coast of India, we had cyclones. So we were, by April, May, we were waiting for the monsoons to arrive. But at first we had the heat waves, the very strong Indo-Pak heat waves from parts of Pakistan to northwest India to parts of southeast India. These heat waves covered. You can see some of the temperatures went above 50 degrees Celsius, record temperatures over parts of northwest India, having a huge impact. So, and after the heat waves were quickly followed by 2 cyclones, one on the east coast, Cyclone Amphan, one of the strongest cyclones, which was on par with the 1999 Odisha cyclone. So this came over the Bay of Bengal, hit the east coast of India, went through the Sundarbans over the north. And just 1 week after that, we had this was a back-to-back cyclone. We had Cyclone Nisarga hitting the west coast. And this was in June, early June, along with the monsoon. So monsoon had barely started, we had Cyclone Nisarga. So this was an unprecedented event, because we generally don't have cyclones during the monsoon season, because the monsoon winds are not favorable for cyclone development. So these 2 cyclones we got, and on top of that, we had the locust swarms coming in from the north. So it actually started in the East African Peninsula, then flowed over to the Arabian Peninsula, then moving over to Pakistan and India. So this was huge, and then it came, it covered many parts over North India and came south until, I think, Karnataka. There were many observations of these locust swarms. These are still relevant in some regions in northwest India. So many of these extremes, which we see here, have an oceanic origin, which is quite interesting, and which I will explore briefly in this talk. And they're fueled by warm temperatures, particularly warm ocean temperatures. So warm temperatures associated with global warming, they warm the atmosphere. You have a lot of moisture, a lot of temperature, so it can trigger many extreme events. We will see how. And again, in 2020, once the monsoon started, we had quite many floods across India. We had Kerala floods again, but not as big as the 2018 or 2019 floods, but still devastating Kerala floods. We had the Mumbai floods. Mumbai now have floods almost every year now. It's very often. We have floods in Kashiranga, Northeast. So that is one of our story here. And so we had floods across, and most of these floods are recurring. We can see that Kashiranga is getting flooded almost every year. Mumbai is flooding almost every year. Kerala floods are usual nowadays, at least in the last few years. So before getting into all the science of extreme events, let us have a look at how climate change is happening, how carbon dioxide has a role in it. So I've used a cartoon. It's quite boring to give almost a 45 minutes, 1 hour long talk without having some tidbits like this. But this is a cartoon from Calvin and Hobbes. Many of you might have read Calvin and Hobbes. It's one of our and our
Dr. Roxy, your network is perhaps a little flaky. You're breaking a bit.
Can you hear me now? Can you guys hear me?
Yes, yes, yes.
Okay. So I mean, was I audible until now?
Yes, there was just a small, brief, few seconds. Please go on. Thank you.
Okay. Okay. Perfect. Yeah. So here you can see Calvin is asking his mom about greenhouse gas effect. So we can see again and again, particularly in the US and many other countries, people asking if climate change is really happening, if it is happening. And then in the second panel, we have the science being explained. So what is greenhouse gas effect, or how is climate change happening? So we have these emissions, carbon dioxide emissions from industrial emissions and all, which particularly carbon dioxide. So this additional carbon dioxide in the air that traps the sun's heat and atmosphere warms, it's going to melt the polar ice caps. So that is one thing, that's the science behind it. And the thing is that Calvin says you will be gone when it happens, but I won't be. Nice planet you are leaving me. So that is another point here, because carbon dioxide has a particular property. It has a long lifetime. So whatever carbon dioxide we have emitted now will remain there for hundreds of years, and the impact will be there for hundreds of years as well. And how do we respond? So Calvin's mom says, this is from the kid who wants to be chauffeured any place more than a block away. So we don't do anything about it. Or the nations, as nations, we are not doing much about curtailing carbon emissions or climate change. So that is a bit of science about carbon dioxide and climate change. So if you look at greenhouse gas emissions, 76% comes from carbon dioxide and rest from methane and nitrous oxide. These have a much more higher potential for warming the globe, but the emissions are more towards the carbon dioxide, and we know more about carbon dioxide as well. So a larger portion from carbon dioxide for the warming we are experiencing, and a large portion of these carbon dioxide emissions come from fossil fuels, from industries and motor vehicles and all. And if you see, since the industrial times, so pre-industrial is roughly about 1850s, 1870s and all. So during that time, the carbon dioxide concentration in parts per million was about 280. Now it's almost doubled by 2020. It's around 415 parts per million. So that's a huge increase in carbon dioxide, increased by 48%. That's the atmospheric levels, yeah. And as we saw in the Calvin and Hobbes cartoon, a lot of this carbon dioxide is trapped by the atmosphere, and it warms the atmosphere. And where does this heat goes? I think and there has been a lot of talk that since we are having a pandemic and COVID, a lot of industrial production has been is going down, economy is going down, so maybe carbon emissions are also down. It's true, in fact, there is a temporary reduction in daily global carbon dioxide emissions. This is from a paper published in Nature Climate Change. So what they are saying is that since April 2020, there is a 17% decrease in the carbon dioxide emissions. So this is in carbon dioxide emissions, not the total concentration. So this is what you can see. So the emissions in metric tons of carbon dioxide per day. Yeah. So from 40 in 1970s, we had reached about almost 100 metric tons of carbon dioxide per day. That's the per day emission. Yeah. And because of the pandemic, there was a temporary reduction. And you can see month-wise also how the reduction is going from January, February, March, April to May. So there is a temporary reduction in carbon dioxide emissions. Now the factor that I told earlier was a carbon dioxide concentration. So even though the emissions go down, the present day concentration, that won't decrease. There is a reason for that. That is because of the long lifetime of carbon dioxide in the air. So like Calvin says, so we all will be gone, but the carbon dioxide that we have in the air, it will take a long time to disintegrate and mix with the atmosphere. So that is what you see here. Let me see if I can use a highlighter. So yeah. So you can see on the y-axis, this is the carbon dioxide. Suppose I stop all carbon dioxide emission today and call it as 100 units. So suppose I emitted 100 units of carbon dioxide and I stop all emissions. And I'm 40 years old now, or past 40. So it's the time in your life when you're past, the time you spend in past and your future is almost same, and you start thinking about life. And suppose based on the average lifespan, I live for 40 years. So this is the 40 years I'm marking here. So the carbon dioxide I emitted now, you can see how much it will still remain. So 50% of that carbon dioxide will still remain in the atmosphere, whatever I emitted. So which means the carbon dioxide lifetime is quite huge or long. So even after 100 years, you can see 40% of the carbon dioxide still remains. And a lot of this carbon dioxide is absorbed by ocean, but still that is a very slow process. So even after 1,000 years, you can see the years here on the y-axis, on the x-axis. So even after 1,000 years, about 20 to 30% of the carbon dioxide remains. So that is like the grandchildren's grandchildren and their grandchildren, still the carbon dioxide I emitted will remain there, at least 20%. So that is the impact of carbon dioxide on the atmosphere. Yeah. So that is a point, that's a take-home message, which means that many of the extremes here are here to stay, unless we find a method to sequester, capture back the carbon dioxide from the atmosphere. So now, where does all this carbon dioxide and the temperature, extra additional temperature from global warming goes? As you see in this figure, a large amount of this global warming, the heat from global warming, goes into the oceans, which is why we don't see a large change in our temperature over the land and atmosphere. So 93% is huge. And the atmosphere, land and ice takes up only less than 7% of the global warming heat. And this is because of property of water. So oceans are a big, deep reservoir of liquid with high heat capacity. And almost all of Earth's heat gain goes into the oceans. That's like 8 into 10 raised to 21. That is zeta joules per year. You don't have to bother about the units and all, but here is a good way, easy way to imagine. Imagine all the electricity we produce yearly and multiply it by 150. 150 times the electricity we produce yearly. That is how much heat oceans absorb every year. That's huge, right? So there could be repercussions, and that comes through changing the atmospheric conditions, changing the weather, changing the climate system. Now this is a very, I'm trying to explain the impact of warmer conditions on the weather, on the climate system. Now suppose we have warmer ocean here. I put a image here on the right side. So when you have warmer ocean, it keeps the air warm and humid. And warm, humid air means it's lighter, less dense. It makes the air unstable and changes the atmospheric circulation. So there is a lot of, it's a simplistic way of seeing it. So basically, you just have to understand that warm ocean makes air warm and humid and changes the weather conditions. So that's why we have many extreme weather events across the globe. Now, coming on to the biodiversity, I told you that I will tell in stories. So if it was an interactive session where I could see you all, I would have asked what is the story behind this picture? Now, this picture was taken from Jaipur recently, just last month. It's a Dr. Saurabh Kalia took this picture from Jaipur, and it's of a blue-cheeked bee eater. Many of you might have seen bee eaters flying across. They eat bees, insects, all kind of insects. But the point of interest is not the bee eater, but the insect in its mouth. That's a locust. Locusts are like almost like grasshoppers. And these locusts, I told you about locust swarms. So for a bee eater in Jaipur, locusts are not common food. So this is something interesting change to their diet during this season. So let's see how this locust ended up in this bee eater's mouth or beak. So I told you I'm not a biologist, but I have huge interest in biodiversity, which is why we are exploring these aspects. So let's see how ocean warming might have induced these locust swarms. So here's a picture of locusts racing over some crops, agriculture crops over parts of India, I guess. So I told you how the locusts started in East Africa and then moved on to Arabian Peninsula and then to Northwest India. So how did it start? So for that, we go into the the Western Indian Ocean region. Yeah. So I'm marking the Western Indian Ocean region here, which is close to East Africa, and I'm marking the Western Indian Ocean here. So if you look at the bottom left image, this is a image of the temperature distribution of the ocean temperatures of the Indian Ocean. And I have colored the temperatures which are generally about 28 degrees Celsius. So about 28 degrees Celsius, you have these warm red colors. And below 28 degrees Celsius, you have the yellow colors. So generally, when the temperatures are below 28, below 26 degrees Celsius, it doesn't support cloud formation or convective activity. You need warm temperatures like that in the warm pool region, noted here, for very active convection. So generally, until now, the Western Indian Ocean region, WIO, was generally cooler. It doesn't support rains, yeah, which is why generally over East Africa and all, you don't have much rains. But now, if you look at the bottom right picture, you can see, so I have taken the Western Indian Ocean. This red line here is the temperatures of the Western Indian Ocean. So earlier in 1900s, you can see the temperatures are around 26 degrees Celsius. By 2010s, the temperature is about 28 degrees Celsius. That's a quite monotonous. There are some interannual variability, year-to-year variability, but you can see the temperatures of Western Indian Ocean has increased, and they have reached temperatures of around 28 degrees Celsius. Now that is a quite huge increase, about 1.2, 1.5 degrees Celsius increase over this region. So suddenly this region has become convective. Convective cloud formation started there. So it resulted in unseasonal rains over East African region and Arabian Peninsula. So all these rains triggered vegetation over these deserts. So which triggered, some of you might know locusts, when there is sudden vegetation over these arid regions, these locusts starts breeding, desert locust starts breeding, and then they followed after damaging the vegetation over there, they followed the winds and the moisture through the Arabian Peninsula to Northwest India. So Northwest India also had unseasonal rains during March, April, due to a phenomenon called Western disturbances during this time. So all this triggered, so originally triggered from warming ocean and rains, triggered a swarm of locusts covering Africa, Arabia, and South Asia. So these are kind of impacts on biodiversity I'm talking about, churning out of this global warming. So other extremes, we talked about cyclone. So one peculiar or strong cyclone was Cyclone Amphan. It's so beautiful to look at, but devastating to have the impacts. Even for cyclones. So cyclones, the characteristics of cyclone is you always hear cyclones forming over the ocean, right? Why? Because cyclones draw their energy from the warm waters over the ocean. So here, what we saw was the ocean temperatures in the Bay of Bengal prior to Amphan were about 30 degrees Celsius to 33 degrees Celsius. So you can see in the images down. So this is based on satellite data over long term. So if you look at Bay of Bengal here, these are the ocean temperatures normally during this time. You can see the temperatures, temperature values here. So the deep yellow are 28 degrees Celsius up to 30 degrees Celsius, right? Let me change this, up to 30 degrees Celsius. So that is the normal temperatures over Bay of Bengal. But I see someone else is trying to draw. I don't know yeah, okay. So, but if you look at what happened just during Amphan, you can see that just prior to Amphan, the temperatures there were between 30 degrees Celsius to 33 degrees Celsius. Now these are high temperatures which we have never recorded in Bay of Bengal using our instruments. And it is these high temperatures that led to a rapid intensification of Cyclone Amphan that we see here over Bay of Bengal. And so generally cyclones take a longer time, maybe 2 or 3 days to intensify from a category 1 cyclone to category 5 status cyclone. But in the case of Cyclone Amphan, it developed from a category 1 cyclone to a category 5 cyclone in just 18 hours. That is like overnight. So you go for the sleep saying that it's a category 1 cyclone, and you wake up to a category 5 super cyclone. That's how this cyclone intensified thanks to the warm waters in the Bay of Bengal. So generally, the ocean is warming, and there is a huge impact across India. And now we shift on to story number 2 and 3. You can see the tiger over there. the famous Indian tiger or the Bengal tiger and the one-horned rhinoceros. Yeah. So this shows two contrasting aspects of changing climate. One is of dry conditions, browning conditions, brown vegetation. One is of wet conditions, right? Flooding conditions. So let's go on to this story. So I will show a figure again, a scientific figure, but I will try to explain it very simplistically. So the first figure that we see on the left shows the change in rainfall, the total rainfall we get during the monsoon, summer monsoon period, during the past 50+ years, right? And you see all the blue colors. So all the blue colors show where the monsoon rainfall, the total monsoon rainfall has decreased over time. And that means we are having more drier conditions, long-term drier conditions. But at the same time, if you look at the map on the right, you can see, I am circling again, the red colors show the change in extreme rain events. So all those red colors show where the extreme rain events are increasing. So this is very puzzling. Which means that the drying conditions are happening along with the extreme rain events. So what does it mean? So if you look at the graph below, it shows the changes, long-term changes. It's a gradual long-term change. So you can see the gray line shows how the rainfall has been decreasing over time. And in the opposite direction, you can see extreme rainfall events increasing. So this is something peculiar happening with India, which means that we are having more dry periods intermittent with heavy rainfall events. And this has an impact on the biodiversity as well, the vegetation over India. So there has been a study on tiger reserves, how the vegetation over tiger reserves are changing. So this is from the National Wildlife Institute in Bangalore. And what they are showing is that many reserves across India, that's shown here, many of them are drying or browning. And on the right hand, I know it's difficult for you to read the text and all. So it is the name of many of these tiger reserves and how much decline. So the brown color shows the decline in area. So almost most of these show more than 50% decline in decline or drying of these tiger reserves, which means that there could be a huge impact, climate change element or the decrease in rainfall over these tiger reserves. Now, so that's a major impact because monsoon patterns are getting irregular, which means, as I said, long dry periods intermittent with heavy rains. So it's like you are waiting for the rains, but it doesn't rain at all for several days. And suddenly, all of a sudden, you get all the rain all of a sudden. So that is the extreme rainfall event. So one day, day 2, day 3, you don't have rain. Day 4, you have heavy rains. So that's the kind of impact we are having in terms of the monsoon. Now, story number 4 is of a rodent. I just want to confirm that I am audible to you all.
Yes, you are audible. Thank you.
Oh, perfect. Yeah. So this is, I'm sure most of you may not have heard about this, this rodent. This is from the fringes of the Indian Ocean. And this is the first mammalian species to have gotten extinct due to climate change. So let's go into the story. So the story links with sea level rise. Yeah. So we have marked here some of, you can see the purple lines. So this is one region which is heavily impacted by sea level rise. So I told you about, so Calvin earlier told you about melting ice caps and all. So that adds a lot of volume of water, which increases the sea level. And also at the same time, there is another property of water. When the water is warmer than usual, it expands. So both these properties induces a lot, increases the sea level across the Indian Ocean. And most of the vulnerable nations and low-lying nations with bellowing population lies around the Indian Ocean. So the sea level rise is huge around this region, and the impact is already felt. So how do we study this sea level? So the map on the right shows, you can see many dots over there. So those are just instruments, so called tide gauges. So we have tide gauges across the Indian Ocean, particularly along the coast, which measures the sea level changes over time. Some of them have been there for hundreds of years, some 50 years. So I've been getting a call for long. So let me disable my audio. Yeah. So if you look at the long-term change, you can see that the sea level rise, global sea level rise is around 3 to 6 centimeter per decade. Now we might think that's not large, but if you really know, some of the islands and some of the low-lying lands are just few centimeters. Some are like 10 centimeters. Islands in the West Pacific, they are like 10 centimeters. So if you consider the sea level rise as 5 centimeter per decade, in 100 years, the land which has been engulfed by sea will be about 50 centimeters. That's like half a meter of land taken by sea, right? So the sea level change is quite huge when you consider long term. And you can see that this is a measurement from Mumbai, which shows a continuous sea level rise. From Kolkata, again, the sea level rise is much more larger. Kolkata is around 5 millimeter per year, that is 5 centimeter per decade, or Mumbai is around 3 centimeter per decade. And this is because of non-uniform ocean warming. So sea level changes happen due to melting ice, which Calvin told you earlier, but also due to ocean warming. That's because water expands as it warms. So the volume of water expands over the ocean. So which is why we have a huge impact due to sea level change. And this has impacted the biodiversity as well. One is on the Bramble Cay Melomee. So it's on the fringes of Indian Ocean in an island near Australia. That is the first species to be extinct due to anthropogenic climate change. So what happened is that over there, the sea level rise was about 7 millimeter per year. And this island, this Bramble Cay Melomees, they were that was the only island where these Melomees were found. And because of sea level rise and extreme tides and storm surges, this region was totally flooded and driving these species to extinction. So that is a story from nearby, but we have stories from India as well. Many of you might know about Gulf of Mannar. It's a region south of Bay of Bengal, south of India. And there used to be a beautiful island called Wan Island. So this is a picture of Wan Island few decades before. And this is a picture of Wan Island now. You can see the impact of sea level. Yeah, that beautiful island is going down. So a few centimeters of sea level rise over a long time can have a huge impact. Now, what do we do about it? So there has been a lot of, all the extreme weather events we have seen, humans are trying to adapt to it, trying to mitigate these events as well. So one way is through coral reef restoration. The other way is through seagrass restoration. So this has been reported from, again, from Gulf of Mannar. So what they are doing is they are trying to have artificial reefs deployed on this region nearby Wan Island. The other tactic is to have seagrass restoration, which you can see here. So many marine biologists, they have been trying to, in different methods, they are trying to regrow seagrass in this Gulf of Mannar side, and they have been having success in restoring some of the seagrass over this region. So you can see this is called gardening back the biosphere. So there are options if you look at, if you study nature, if people like you are interested in nature or working with environment, there are many options for bringing back the biodiversity, and you can see the impact. So down here again a chart, but it's easy to explain. So the top line which you see here is the control site. So there where the seagrass is already there. Okay, this is the fish abundance over this region. So there you already have a lot of fish abundance, so it doesn't matter. But if you look at the restoration sites, so there was no fish in July, August of 2014, but it became much more abundant and almost equal to the control site by by May 2016, which means that restoration efforts like this, gardening back the biosphere, can really help. Now, coming to our last story, it's a story of the corals. What you see is the coral before heat waves over the ocean. Heat waves happened over the ocean, and after the heat waves. So I think time is running out, so I will go through it quickly. So again, coming to coral reefs. So coral reefs occupy only 1% of the planet's surface, but 25% of all the biodiversity is found among the coral reefs. And one important property of coral reefs is that they have a specific temperature range between 18 to 28 degrees Celsius. That is the usual temperature range. So when we have heat waves in the ocean, it bleaches and kills the corals. So that is a huge impact which we are seeing. So the same heat waves which triggered the temperatures which triggered the cyclones are killing the corals as well. So what is happening to the corals? So if you look at this picture here on the left, you can see the corals are all white. That is because the corals got bleached. This is again from Gulf of Mannar. You can see that from the Marine Research Institute in Tuticorin, they are showing that since the last several years, there has been a huge decline, 39%, 23%, 25% of decline in the coral cover over this region. And this is because corals have a mucous membrane. It's called zooxanthellae. Yeah, and this is what provides them with a shield and their color. So warm waters bleach the zooxanthellae away. So that's how the coral bleaching happens, and it damages the conditions over there. So it's the same ocean conditions which we saw earlier, that intensified cyclone Amphan, that led to the coral bleaching in Gulf of Mannar also. So that's like a lot of events, and if we put them all together, these events are acting together as well, and we call them compound events. You can see this condition from India is much similar to the compound events in nature. So we have the rains on top. One umbrella is not sufficient. We have the water splashing from the car, from the bus. Someone spitting over here. Again, pool of water here. So many impacts are acting upon together, right? So, for example, if you take a city like Mumbai or Chennai or Visakhapatnam or Kolkata, suppose this is that city, most of them are near the sea. So they are faced with sea level rise, storm surge and waves, heavy rainfall, and together with a flooded river. These events, multiple extremes can overlap and damage a city and its outlying regions. So that is one kind of compound event. Similarly, dry conditions, water scarcity, and heat waves, and melting of glaciers, all these can act together. So the impact could be huge when these events act together. So similar kind of events happen over many places, many cities like Mumbai. The recent cyclone Nisarga hit Mumbai, south of Mumbai. Mumbai was almost saved from Nisarga because it hit some 60 kilometers away from Mumbai. So What you see here, it looks very beautiful. It's a picture from Johnny Miller called Unequal Scenes. You have the high-rise buildings and you have the uh, blue shaded slums down south. So this is a Dharavi, and these are low-lying lands which are heavily impacted by these compound events. The blue shades what you are seeing are the polythene, not the polythene. It's the shades they have put to the plastic shades they have put to save themselves from the extreme weather events. So the most populated, densely populated cities like this, which do not have climate change plans, and where the lungs of the city, you can see there are no more mangroves here. Mangroves were supposed to be the floodplains of the city. There are no more rivers here. The Mita River is supposed to be flowing through the middle. You can see that it has been uh, 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 it has gone down into a small canal. So we have to be aware of this and work towards mitigating these events. Similar events, common events are happening uh, over the marine system ecosystem as well. You can see the with a cyclone, just after a cyclone is hitting, the corals are devastated, are damaged, and along with that, if you have the marine heat rays also, the Susandale, everything is gone, the coral system is gone. So we have to be aware of these marine events as well, compound events. So the one way to act upon, timely is to predict these events. So we can't say, okay, it's all gloomy. We are having hurricanes, desertification, droughts, all leading to rapid collapse. So what do we do? So does it matter if we can predict these events? It does matter. And I'm showing in this second last slide how we can predict these events. So if you look at the case of Odisha cyclone, we had a loss of human life in 1999 running to 5 digits, 10,000s of people were lost. Yeah, but due to accurate prediction, we were able to bring it down to 2 or 3 digits. So 21 people in Filin, very super cyclone, and Amphan super cyclone around 100 only. And that happened due to accurate prediction only. So cyclone focus have improved and lives are saved, but cyclone characteristics are becoming erratic. That's because of global warming, because there is rapid intensification and all, and our climate models are not able to pick them up. So one way is to follow the climate change policy, make sure that it is implemented. We have India has a climate change policy, but it needs to be followed up. We had promised, we had a huge target to do by 2022. That is about 100 gigawatts of solar energy, but we are nowhere near. We have done about 30 plus gigawatts, which is for a developing country, that is huge. That is to be appreciated. But we need to follow up that and grow our renewable energy resources. So extremes are here to stay. Impacts are here to stay. We need to adapt and mitigate. But there is something more that we can do. We can innovate. We can probably innovate for efficient energy systems. We can innovate for how to capture the carbon dioxide back. So there are many ways. So I hope through this talk, I gave you a glimpse of the extremes happening in our land and atmosphere and ocean, and how it impacts the diversity, both over land and over ocean. Thanks a lot. I hope there are messages from me and Calvin and Forbes as well. Thank you.
Thank you, Dr. Roxy. That was an extremely enlightening session, and I think very, very relevant and very, very important in these times of extreme events. We are now open for questions. If anyone has a question, you can unmute yourselves. Request whoever wants to ask a question to state their name and keep the question brief and to the point. But we are open for questions now. Thank you. So yeah, do we have? You can also put it in the chat box if you are having issues with the audio or whatever.
Yeah, I'm unable to see the. So let me see if I can see the chat. Okay, so one question is from Dr. John C. Mathew. He is asking, when we promote solar energy, how best we can reduce the pollution caused by the manufacturing solar panels? Yeah, what we have seen is many of the alternatives provided for saving energy are themselves expensive, or we end up uh, making more emissions. So I'm not an expert in understanding the pollution or the carbon emissions caused by manufacturing solar panels, but what I understand is that the benefit, the long-term benefit, is much larger compared to the manufacturing of solar panels from in terms of saving energy and keeping the carbon dioxide out of the atmosphere. I don't have a quantified values yet. Yeah. So this is Tushar asking what is the role of increasing atmospheric aerosols? So in my talk all over, I was talking about carbon dioxide emissions. So this is in gaseous form. Now, atmospheric aerosols are like pollutants or particulate matter which are suspended in the atmosphere for longer times. So this interacts with the solar radiation. So when you have pollutants in the atmosphere, it can either absorb solar radiation or reflect solar radiation. Sometimes it can interact with the clouds. So this is something which has been quite important when we talk about climate change, especially in the recent years, because pollution has been increasing over many of the countries, especially developing countries are, pollution is a major factor, like for Beijing or Delhi and other cities as well. So they interact with the climate system. We have seen there is an impact on the monsoon as well. So what we are seeing is that though the total monsoon rains have decreased, the atmospheric pollutants which are suspended in the air, they have a property of increasing the convective activity locally. So there is a balancing effect happening over the Indian region. So, but the problem with atmospheric pollutants or aerosols is that there are different species. There are sulfates, there is black carbon, there are many species and their properties are different. There is a lot of uncertainty on that. So Mohan Kedas says, an excellent initiative. Is there any relationship established between atmospheric variables and COVID-19 spread? So one, I talked about COVID-19 and impact on emissions, but again, there are some recent studies which are shown that the atmospheric pollutants or the aerosols which I talked about, how it has changed during COVID. So there was a drastic reduction in atmospheric pollutants during COVID-19 because there was the industries were down and there were no cars out there. So during this time, we had a lot of solar energy coming in. So I had shown you one example is how the sea surface temperatures over Bay of Bengal might have changed. So when there are no atmospheric pollutants, one possibility is that it has also helped in increasing the temperatures, local temperatures, and helped in aggravating the cyclone. That's a possibility which has been, some of my colleagues are exploring that. So there are these interesting interactions due to COVID as well. So there is another question, let me see, from Sriram Iyer. So the sun's energy is entering the Earth's atmosphere. Though most of it radiates off, some percentage stays in the atmosphere because of gravity. Since this is trapped here and it's not escaping, isn't it natural that the temperature goes up slowly? Is it the carbon dioxide that's causing it? So one clarification here, the reason why the sun's energy is being trapped is not because of gravity, but because of the greenhouse gases which are already in the atmosphere. So the reason why we are not a frozen planet, the reason is that we have greenhouse gases like carbon dioxide. So generally we have a particular amount of carbon dioxide, say for 280 ppm concentration carbon dioxide. So this concentration has been same for several decades in human history. So the amount of solar energy which is trapped every day used to be the same, but now the carbon dioxide concentrations are quite high, and it increasing day by day, year by year, which is why there is more solar energy being trapped. That's a very basic property of greenhouse gas emissions. So there are more questions coming up. Himadri Saini, Himadri, she was my student. So does the increasing or decreasing acidity of ocean water impacts marine heat waves? So I have seen that marine heat waves impact acidity. So acidity is the pH content of water. So because of increasing temperature and other conditions, the water is becoming, the pH level of water is changing, and this is having a huge impact of these shell producing organisms in the water. So we have seen such impacts, but I don't know if I don't think there is a impact in the opposite way, where the change in acidity impacts the marine heat waves, because the change in acidity is not that large to change the temperature conditions. Thanks, Sriram and all. And Manas said, can we invent discover some kind of system which could reduce the amount of carbon dioxide which is present in the air? If we could do so, we could reduce the impact of climate change. Yeah, this is a question many of us have been following. Yeah, and even yesterday I saw that there is a paper which came, scientific paper which came out saying that they have found a novel way of extracting carbon dioxide using some materials found under the surface of Earth. So there have been many attempts of sequestering, we call it sequestering of, or storing carbon dioxide, but most of them have been very expensive. So one of the methods I showed, seagrass restoration, right? So a lot of carbon dioxide is absorbed by the oceans itself, by the phytoplankton, by the plants in the ocean also. So if we can replicate the seagrass across the ocean, that is one way where carbon can be sequestered naturally as well, and also help the biodiversity. So far, everything has been expensive. We need innovation to find better ways to capture carbon dioxide. Ipsida says that the precipitation, that the rainfall is decreasing and extreme events are increasing. Is there any particular reasons behind, or can we relate these two? So the rainfall decreasing is largely due to changes in the monsoon circulation. It's a bit complicated to explain both together. So the monsoon winds have decreased, especially over the Indian domain region during the summer period. But at the same time, it's showing more fluctuations. Yeah. So even though the winds which carry the moisture have weakened, so during some period the winds are strong, some period they are weak. During the strong period, we call it episodes. During these episodes, it carry a lot of moisture, and a lot of moisture is available in the Arabian Sea because of warm conditions. There is a lot of moisture. So when the winds are strong, it brings in a lot of rain. So we have these spells spanning for 2 to 3 days, like we saw over Mumbai or Kerala, which are heavy spell rains. Question by Sharavana Kumar. After watching a documentary called Cowspiracy, I haven't seen this documentary, there is a new data on the huge contribution of agriculture and animal farming for meat and dairy products, causing a bigger impact on global warming than fossil fuels. Oh, I see that there are a lot of messages down there. So I don't know if
Yes, I was going to stop you there. So I think in keeping time in mind, we can perhaps take just two more. So I think the conspiracy thing is talking about the methane gas emissions and whether that is a bigger impact, because that's another theory that's coming up. And I think we will just take a couple of more questions and then we will thank you all. And we're sorry we can't handle all the questions just simply because we don't have the time for it at this point.
Yeah. So the best thing would be to do. So I will answer two questions and then we can. So I am available through email and other ways. You can just Google my name and we can explore further. So the agriculture conditions, yeah, sure, and agriculture not only through cows but also through farming and burning crops also. So there is a lot of methane coming out from them, and also due to the normal type of global warming, global heating, the ice caps are melting. So there are many methane storage under these ice caps. So I told you earlier that methane has a higher potential than carbon dioxide. So the problem now is that we see that there is methane coming out, but so far the ratio of carbon dioxide is quite large. And there is another problem that we don't know how much the impact of methane is, how much methane has been coming out so far. So there is some uncertainty lying down there, which we really need to explore. But the impact which we see from carbon dioxide is real, and we are seeing both the science and the observations show that. And thanks. Yeah, we did ask if land warming also affect the extremes. Of course, land warming affect extremes. I think even now we had the heat waves, and in the month of May, followed by lightning, right? And lightning happened because the monsoon rains, some of the monsoon rains reached those places earlier, like UP, Bihar and all. So the clouds were not totally monsoon, I mean, full-blown monsoon clouds. And at the same time, local atmospheric convection was there because of a lot of heating, resulting in all those lightning and all. And many extremes are happening around this. So more we can explore later. So
I think fair enough. Yeah, thank you so much for taking time out on a Saturday evening. We appreciate that, and thanks to all the participants who also made it to this session. It was a very informative and very enlightening session with all the snippets from Calvin and Hobbes to fill in the philosophy. Yeah. So, and like Dr. Roxy had kind of indicated that because we're not able to take any more questions now, please feel free to get in touch if you should have something. Thank you all for joining in, and we hope you will come back to us and stay with us for the few other webinars that we have in store. Thank you once again, and thank you, Dr. Roxy Mathew Koll.
Yeah, thanks a lot, everyone. Thank you.
Thank you very much.
Thank you, man. Thank you, Mohan.